Hey everyone, in this video we're going to be talking about gears in general and specifically looking at one more force analysis example. This video is part of a lecture series on mechanical design 2. So we have shaft A in the figure has a power input of 75 kilowatts. So we have shaft A has a power of 75 kilowatts. We're told that in the question at a speed of 1000 revs per minute in the counterclockwise direction. The gears have a module of 5 millimeters and a 20-degree pressure angle, and gear 3 is an idler. So if we have an idler, we know that the sum of torques is equal to 0. And the first step is to find the force F3B that gear 3 exerts against shaft B. And then we're going to find the torque for C that gear 4 exerts on shaft C. So the first thing we can do is we can label that the direction is going to be counterclockwise for A. And that means that B is going to rotate clockwise and C is going to rotate counterclockwise. And based on that, we can also look at a diagram of, we can do a free body diagram of gear 2 to start with, because gear 2 is where we have our input power. Okay, so I'm going to draw gear 2 on the right side here. And I'm just going to label this gear 2 with the different things that are going to happen. So we're going to have a contact point at the top. And at the top, we're going to have a force F32 with a tangential component, so F32T, and a radial component, F32R. And we also know that our shaft A is in the middle, and we have a torque being applied called torque A2, so torque A onto 2, which has a certain torque, which we can find if we want to. And we also know that the power is 75 kilowatts at 1000 RPM. Okay, and if we know that, we can therefore from there find what our WT is going to be equal to. That's going to be our first step, is going to be to find WT, so that we can then find other things later on and find the forces on gear 3. So WT is equal to F32T. Okay, so that would be the force 32T is going to be equivalent to WT in the direction given, which is equal to 60,000, because we're using SI units, times 75 kilowatts over pi times D2. So we need to find D2. So in order to find D2, we can say that D2 is equal to the module times N2, which is equal to 85 millimeters. Okay, so we have 85 millimeters multiplied by 1000 RPM. And so we get a value of 16.85 kilonewtons. Okay, so that's our first step. The next step, in order to find our F3B, is to find all the forces that are acting on shaft B based on gear 3. So all the forces on shaft B are just based on gear 3 in this case. We only have one gear connected to shaft B. So if we can get all the forces on gear 3, we can therefore get all the forces on shaft B through that. So we're going to find F3B by looking at the free body diagram and analyzing that free body diagram of gear 3. So if we look at gear 3, we have a top contact point and a bottom contact point. And the bottom contact point is going to have a force in this direction, F23, okay, with a tangential direction, F23T, and a radial direction, F23R. Okay, now notice how I didn't even have to find F32R. I might have to find it later, but for now it seems like I don't have to find it at the moment. So we'll see if we need to find it later on or not. Then we have to also draw our force from 4 onto 3. So if it's rotating clockwise, the force from 4 onto 3 is going to be against that motion. So 4 to 3 is going to look like this. F43 with a tangential component, F43T, and a radial component, F43R. and we have our shaft B in the middle, and we're gonna have some sort of force, some sort of reaction force on in the middle on the shaft, okay, to resist those forces. So if we look at the two forces together and we know that all the forces are transmitted throughout the idler, it would make sense that the force as a first assumption would be in the direction to the right. So FB3 would be to the right. Okay, it would be countering our F3B. Okay, now some of the things we can say about the idler, we can say that the sum of torques is equal to 0. And we can also say that because it's a gear and it can't move in space, the sum of forces in X is equal to 0 and the sum of forces in Y should be equal to 0. Okay, and we can equate these forces by doing that. So the first thing we can do is we can say, okay, let's figure out what our forces are. So we could use the sum of torques is equal to 0, and we know F23 already. We know F23T already from our previous gear. Now, do we also know F43? Yes, we do, because it's the same reaction force, just in the opposite direction. So we actually know F43 immediately. We don't actually have to use the sum of the torques this time, because we only have one idler. We don't have two idlers. So we can use these relations to figure out what is our FB3 or our F3B essentially. Okay, so the first thing we can do is we're going to try and find FB3 first. So we're going to say that 0 is equal to FB3 in the direction. So we're going to say that this is positive X and positive Y. And we're going to do that the sum of forces is equal to in the X direction is equal to 0 first. So we have FB3 minus F23T minus F43T. They're both in the negative direction. And we can rewrite this as, if we rearrange this, we can say that FB3 is equal to F23T plus F43T. And we get a value of 33.7 kilonewtons. Because we know that F23T is equal to F43T. They're on the same gear and they're going in the same direction, so they're equal. So it's just double the value. Okay, so now we found FB3, essentially the reaction force of the shaft. Now what we're asked to find is actually F3B. Okay, so the opposite of that. So F3B is just going to be in the negative X direction. It's going to be negative 33.7 kilonewtons in the X direction. Now, I skipped a step here. Okay, I skipped a step because I didn't do the sum of the forces in Y is equal to 0. Why didn't I do that? Because the only forces in the Y direction are the radial forces, and they're going to cancel out. So we know that F23R is equal to F43R in magnitude, and one is going up, one is going down. Therefore, there's no reaction force in that direction, okay? They cancel out. Okay, so that's why we just don't do sum of forces in Y. It's not necessary. Okay, so we get that F3B is equal to minus 33.7 in the X direction. So if we were to draw it on our diagram, we would have FB3 would be here. Okay, I'm erasing B just to show you. So FB3 would be in this direction. F3B would be in this direction. So essentially the sum of the two forces from F23T and F43T. Hopefully this makes sense. And we can discuss this on Monday as well, no problem. Now, in part B of the problem, we're asked to find T4C. Okay, so the torque created by gear 4 onto C. Okay, so we're gonna have to look a little bit at the problem here and try and understand and look at gear 4 now. So if we do a free body diagram of gear 4, we know that we have F3-4 in this direction, and we know that we have shaft C in the middle, and we also know that the rotation of the gear is in this direction. Now, this is a little bit more complicated to not understand, but something that you have to kind of think about, and there's an easy rule to remember this. But so we can first say that F3-4T is going to be equal to 16.85 kilonewtons, okay? It's just the opposite of F4-3T, so it's the same value as before. And you can also find it by WT is just equal to F3-4T as well, okay? So you can find it by WT if you want to. And then we can find the torque in multiple different ways. We can find the torque either from the power, or we can find the torque directly from our relation between WT and the torque, which is usually the easier method. So we can say that torque is equal to WT times D4 over 2, because that's a diameter of 4. So we're going to use a WT for this one, which is 16.85, and multiply by D over 2. So D4 is equal to 5, which is the module, times 51, which is equal to 255 millimeters. And then we just plug in our values. So we plug in our values and we say that the torque of 4C is equal to 16.85 times 255 over 2, okay? And one unit is in kilonewtons and the other unit is in millimeters. So we essentially get the answer, 2,148.4. We get it in kilonewton millimeters, which is the equivalent to Newton meters. So it's 2,148.4 Newton meters if you convert the units, okay? The kilonewton and the millimeter cancel out. Now, the last question I have is, what is the direction of the torque of 4 on C? Okay, is it clockwise or counterclockwise? So a rule of thumb is, in whichever the direction of the force is going onto a gear that is not being driven, so this gear is being pushed by another gear, it's not being driven at the shaft, okay, like gear 2, we have that the torque from the gear to the shaft is actually in the direction of the force of the gear. So that means that our direction of the torque of the gear is actually in this direction. Okay, so it's counterclockwise. Now, if we were asking to look at torque of C onto 4, C is essentially creating a reactionary torque to this force, so it's the opposite. So we have TC4 would be in the clockwise direction. This ends the videos on Module 1, and in the next video we're going to be starting Module 2, so we'll see you in the next video.